The next meter we're going to look at is the one that comes with my kit. I'm going to pour everything in here. And we're going to, this meter, like we said, had self-calibration. Now, by the way, your meters come with instruction sheets. And all you have to do is read these instructions carefully, and you will find everything you want to know about these meters. Now, most of us, we stay limited to our RBTI knowledge, and that's all we want to know is basically how to test our salts. That's fine, and but if you want to know more and know the other things that this meter can do, you should read through your instructions. And with this DiST4 meter, you're dealing with a little bit more frills here that you want to learn about. So, the calibration instructions on this meter, I'm going to just read them directly to you. You remove the protective cap, just like that. And you are going to rinse the probe area with tap water first. I did that. And distill water. Always use tap water first, then distill water. Remove excess water and blot dry. Turn on the meter. That's going to be this button right here. There it goes. It's on. I'm not sure if it can be seen. It is seen. What you will notice is 2 zeros will come up, 0.0, and the meter it'll show the remaining battery power and then go to its normal measurement mode. It already did the battery power. It did that real quick. It's at its normal measurement mode, and what you will see in here is that it says ATC in the corner, and it's which means automatic temperature compensation, so you don't have to worry about measuring the temperature on it. This meter you do, though, amazingly enough. You got to set a coefficient on this expensive meter. And in the right-hand corner, you're going to want to have that set to millisiemens. Remember we talked about that, MS. You're measuring in millisiemens, not microsiemens, millisiemens. And we'll see that when we run our calculations. Time to drink. There is nothing so refreshing as sweetened lemonade. Okay. And the next thing we're going to do is we turn this on, and then it says press and hold the on-off mode button again until it shows Cal in the display. And this Cal is going to be a big CAL you're going to see in there. So we're going to press it again. All right. Here we go again. So we hold it. There it is. Okay. Well, this meter, it's going to say in the display, then release the button immediately. The display will show use 12.88. And then you're going to immerse the probe end into a beaker or cup containing the 12,880 microsiemens standard solution. And then when the automatic calibration is complete, the display will read OK for 1 second. Now this is going to go fast. So I'm going to point it here and let's see if you can see it. I'm going to have my cameraman tell me because I can't see it. Did it go? Did it say OK yet? It might have already gone past. What does it say? Talk to me, camera lady.
1288.
1288. Did you see the OK yet?
Nope.
It may have done so fast that we missed it. That's the one thing I don't like about this meter. It just, boom, right in your, it's just gone. Now it's still calibrating. It's blinking.
Changed.
And there it went. I don't know if you saw the OK pop up, folks. I wasn't looking at it because I had to point it to you.
Just change the numbers.
Deborah missed it, and unfortunately it did show up because while it was calibrating, you'll see that there's a little tiny CAL over there to the left, and it blinks while it calibrates. And unfortunately, that OK comes by so fast, and boom, it goes by. So it's kind of not the best feature in my opinion, but it does what it does. It's calibrated, it's ready to go. And let me tell you another thing. This 12,880 solution may be a few points off. And this meter is going to allow for that. Okay? It's just impossible when you're talking the size of these measurements for a meter to get exact. So don't worry about that if it's a bit off. It's going to calibrate itself anyway. So that's how you do it. I'm going to just go through it one more time for you. So again, we shut the meter off. Again, use your instructions. The meter will come to you from Pike AgriLab, set for the way you want to use it. However, if you have any questions about it, you have all your instructions about how to set the conversion factor and the temperature compensation in here and all that. It's very, very simple. You just follow each instruction. If you have a problem, email me or call me. I'll be glad to walk you through it. Okay? We walk it through together. Give me more practice. So let's again do the calibration because this is the most important. We're going to turn the meter on. It's on. And then we see 0.00. I have mine set for Fahrenheit, 71.7 degrees Fahrenheit here. Like I said, it has automatic temperature compensation, ATC, in this corner. It has millisiemens here. The other thing you would see is PPT, which is parts per thousand. And you have the CAL, little tiny CAL in this corner right down here in the window. And of course here's your temperature, and of course your main measurement's going to be the big numbers you see there. So we're going to hold the on mode, or the mode button, and cal comes up. You'll see it actually what comes up is a cal, and you just let it go and it'll say use. When it says use, you're going to put it into your solution here, and you're going to let it calibrate. Now let's see if we can catch it. I'm going to hold it here until my camera lady, my wonderful camera lady, tells me that she sees it say okay. And anyone out there, yell at me, tell me it says okay. Still blinking?
Okay.
There it goes. We got it. Did you see that? Did you see the okay? Isn't that cool? You don't have to turn any screws. You don't have to do anything. It does it for you. Soon we'll be able to just talk to our test, and it'll probably do everything for us, you know? Now again, I would take this meter, and I would bring it to the sink, and I would rinse it off with probably a good flush of tap water, and then I'd hit it with some distilled water, and then we'd blot it dry, and I would, again, not test with it until it had, 15-20 minutes, enough time to just evaporate any water that would be left on it. All right, so the other issue is how long can you keep your calibration solution? Well, obviously, the school of thought that will be said to anyone is that when you use calibration solution, it should be tossed. Well, I know that everyone is in a different financial situation. This stuff is not very expensive. And if you think you're going to be doing a lot of testing and you're going to be doing it professionally, I would suggest that you always use fresh testing solution. However, I have found that what I would sometimes do is I will take the solution that I've used, I will pour it into another container, I will mark the date on it and mark the reference of what it is, and I will then double check it against against a fresh solution, let's say a month later. And I have found that if you're careful and you don't add water to it, this is perfectly dry, and you put your meter into it and you do your calibration, that both solutions will do fine. And again, I wouldn't do this if I was working with as a professional, as a tester, and people were coming to my office every day and being tested. No, I would not do that. But for my own needs, it's fine, because I know my own personal body chemistry quite well. I know where I'm at, and I'll know if something's way off. So that takes care of how to calibrate this meter. Now you have a calibrated DiST4 meter. And again, whether we were using either one of these meters when we're going to test, the same routine works for each meter. It doesn't matter whether you're using the DiST4 or the DiST6. I will go over the HANA HI8733 because it's a little bit different because of the factor that you don't need to dilute in case there's too much salt. So let us pour out let's pour out some distilled water. We have our calibrated meter. And I thought we would first use a little bit of sea salt. No, I do not use sea salt in my cooking. No, I do not use sea salt for anything except one thing. I brush my teeth with it. Dr. Reams used to use salt for brushing teeth, and I have found it to be fantastic. It is fantastic to brush your teeth with salt. You will never feel so clean, your teeth, until you've brushed your teeth with sea salt. So I'm going to pour a little bit in, just a little bit, because this stuff is very, very salty. And I don't want to go over in the first test. We'll go over in the next test to show the dilution. My graduated cylinder.
Is it there?
All right. So your meter has been calibrated. And what you would do now then, someone comes in, they give you the urine, you've done their sugars, you've done their pHs, and now you would do their salts. And we drop this in, and let's see what happens. Again, I like to stir it. Make sure you get all those bubbles out. And then we have a number in there. And we have 9.93, and it's hanging right there. 9.93. It is not moving. Shake it a little bit more. It is dead on. 9.93. 9.94. As you will see, that 3 out. 9.91. Those little movements mean very little. Okay. So what you would normally do then is you would write down your number. Okay, now remember that is millisiemens. So what I'd like to do here is I would like to show you what this number actually works out to be. If we move the decimal over to microsiemens, we would have to go 3 places. 1, 2, 3. So, when you have a reading of 9.93 millisiemens, that would equal 9,930 microsiemens. So remember that. Always, you're looking in millisiemens here, you can multiply this one by 1,000. And all I did was move the decimal 3 places, because that's how you do that, a simple way. And you get your 9,930 microsiemens. Now, to get your C reading, you need to divide that number by 700. So, 700 goes into 9, nope. Goes into 99, nope. Goes into 993 one time. 700. 3, 9, 2. Bring down the 0. Goes into 2,930. We know it goes 4 times. 2,800. 0, 3, 1. Bring down the 0. Doesn't go quite 2. 14.1. 700. 600 left over. If we bring down one more 0, let's see what brought that one, brought another one down here. If we bring down one more 0, we divide that last number, 700, into 6,000, and that would be 8. Because 8 times 7 is 56, so you'd end up with 5,600. And then 400 left over. These numbers, as I said, really are inconsequential. So make your decision now when you decide which way you're going to write your salts. You are either going to write it as 14C, or you are going to write it as 14.2C. We rounded the 1 up. Or if you want, you can write it as, well, you'd have to finish it out if you wanted to make sure you got this last number here exact. 700 into 400 goes 5 times. And actually, that would cause this number to go up to a 9 if you were rounding off. And so you would end up having a 14.19C. If it were me, I would probably go no further than the 0.2. Okay? Round off to your tenths. We don't need to go any further than that. Now, I forget what we had. This thing shut right off automatically, it looks like. So we had a 9.93 reading. Is there another way to do this without having to multiply by 1,000 to get the microsiemens number? Yeah, of course there is. If you divide by 0.7, you should get the same number we came up with. Now remember 0.7.
The calc.
No. 0.7, to do so, you're going to have to move that decimal over one place, right? So to get the 7, so we're going to go 7, and then we're going to have to move this decimal over too. Every time you move him over, you got to move him over once. I'm sure you all remember that in school. So you're going to be dividing into 99.3. 1, 2 left over, 9, 4, 28, 1, bring down the 3, 1, 7. Does it all seem familiar to you? I'm sure it does. And there's your 8, 56, 4. Bring down the, you said bring down the 0 as well. And what did we come up with? 5 again. And you do change that to a 9 if you want to. So you can either divide your number by 0.7, which is the same thing as saying 700, 1, 2, 3, 1,000, moving it over 3 places. That's all it means. And dividing that into your actual